Okay, so here we've got the general form of a quadratic equation, y equals ax squared plus bx plus c. And we can tell the shape of this graph just from this coefficient here of x squared. If a is positive, or if a is greater than 0, then this is going to be a positive shape quadratic. So we're going to have a positive parabola. It's going to be this sort of shape. If a is negative, so if a is less than 0, we're going to have a negative shape parabola. So our quadratic will look something like this. So say I've got a quadratic y equals 2x squared plus 5x plus 3. The coefficient of a is greater than 0, so I know the general shape. It's going to be a positive parabola. I can check if this is going to cross the x-axis by looking at the discriminant. So the discriminant of this quadratic, b squared minus 4ac, is going to equal 5 squared minus 4 times 2 times 3. So that is 25 minus 8 times 3, which is 24, which is 1. So that's greater than 0, so we know this quadratic is going to have 2 real roots. So to sketch this quadratic, what I'm going to do is complete the square. So because I've got a coefficient of x squared greater than 1, the first thing that I need to do is take 2 out as a factor, so I get rid of that coefficient of x squared. So if I do that, I've got x squared plus 5 over 2x plus 3 over 2. So what I can do now is complete the square of this bit inside the bracket just like I've done before. So that's going to be 2 times x plus 5 over 4 squared. That's half of my coefficient of x minus 5 over 4 squared plus 3 over 2. So this is going to be 2 times x plus 5 over 4 squared. 5 over 4 squared, that's going to be 25 over 16. I'm going to change this 3 over 2 so it's in sixteenths as well. 3 over 2 is going to be 24 over 16. So if I just tidy this up a bit, I've got 2 times, in brackets, I've got my closed brackets here, minus 25 over 16 plus 24 over 16, that is minus 1 over 16. And if I just expand this out, I get 2 times x plus 5 over 4 squared minus 2 over 16, which is 1 over 8. So I've done the first part of completing the square here, and I've got it into completed square form. Another thing to call completed square form is vertex form of a quadratic. Because what this actually tells us, you'll see this when we sketch the graph, is the turning point of this quadratic. Okay, so I've written my quadratic in vertex form. The next thing I need to do is to find where it crosses the x-axis, find the roots of this equation. So to do that, I need to solve the equation 2x plus 5 over 4 squared minus an eighth equals 0. So I'm going to take the eighth over to the other side. So I've got 2x plus 5 over 4 squared equals an eighth. Going to divide both sides by 2. X plus 5 over 4 squared equals a 16th. And I'm going to take the square root of both sides. So I've got x plus 5 over 4 is plus or minus the square root of a 16th, that is a quarter. So now taking 5 over 4 from both sides, I get x equals minus 5 over 4 plus or minus 1 over 4. So x is going to be either x minus 5 over 4 plus 1 over 4. That is minus 4 over 4, which is minus 1, or minus 5 over 4 minus 1 over 4, that's minus 6 over 4, which equals minus 3 over 2. So now I've got all this information, I can sketch my quadratic. So I know that it has roots at -1 and -3 over 2, -1.5. And I also know its turning point from vertex form. I'm just going to sketch this. I know its shape. No, it passes through those points there. I also know that this point where it crosses the y-axis, that is just going to be 0, 3. And I can get that just by putting x equals 0 into this equation here. Now, this point here where the quadratic turns, where it goes from being a negative slope to a positive slope, we call that the turning point of the quadratic. And this turning point is going to be minus 5 over 4 minus an eighth. I actually get this information here from the vertex form of this quadratic. It's going to be negative what's in the bracket for the x coordinate and what's outside the bracket for the y coordinate. So when we've got a quadratic, we've written it in vertex form, it gives us our turning point.